Good morning, students. Today we are going to revise the three lectures of the solid state. As you know, that matter exists in three states, that is solid, liquid and gases. And these three states of matter can be interconverted, means solid can be converted into liquid by providing heat to it. Liquid can be converted into gases by providing heat, and if you cool the gas, means if you remove heat from the gas will convert into liquid. And when we cool this liquid, the liquid will convert into gases. That means what? These three states of matter can be interconverted. Okay. Now specifically in this chapter we are going to focus on solid state. As you know, in previous classes like 9th, 10th, you might have learned the characteristics of solids. What are the characteristics of solids? Solid have definite mass, definite shape, definite volume. The density of solid is much higher than that of liquid. Gases, solid are incompressible. Okay, so these are the general characteristics of solid which you can easily go through. The notes which I have given, I have written 6-7 points of the general characteristics of solid. You can easily read through it. Now, these solids can be classified into two types. First one is crystalline solid. Second one is amorphous solid. Now we will focus first on this crystalline solids. What are these crystalline solids? Crystalline solids have definite repeating pattern. Long range definite repeating pattern. What is this long range definite repeating pattern? If the crystalline solid is made up of two constituent particles, that is A and B, so this is atom A, then this B, then again A, B, A, B. So this has long range definite repeating pattern. This has long range definite repeating pattern. Now crystalline solids have definite shape and definite geometry. Crystalline solids have definite shape and definite property. The main point of crystalline solid is crystalline solid have sharp melting point. Crystalline solids have sharp melting point. What is meant by this sharp melting point? That is, if the melting point is 160 degrees Celsius, if a crystalline solid melts at 160 degrees Celsius, means exactly at 160 degrees Celsius. Exactly at 160 degrees Celsius it will melt. Even at 159 degrees also it will not melt. All the solid will completely melt at 160 degrees Celsius. This is called as sharp melting point. Okay. Third point, this crystalline solids are true solids. True solids, because there is definite repeating pattern. These crystalline solids are called as true solids. Okay, the next point is, now we are talking only about crystalline solid. Here we are talking about crystalline solid. Crystalline solid has the property of anisotropy. Crystalline solid has the property of anisotropy. What is this anisotropy? Now see here. If these two crystalline solids, suppose this is crystalline solid A, sorry, it is made up of two constituent atoms A, then again I will write it as B, then A, then B, again I will go A, and this is B. Okay, so after A it will be B, then again we will go for A, and this is B. Okay, now this is A, go A, so after A there will be B, then again A, now look here students, now we will see what is anisotropy or anisotropy. What is anisotropy? If I measure the property of this crystalline solid in this direction, if I measure the property of crystalline solid in this direction, I will get both the constant particles A, B, A, B, A, B. But if I measure in this direction, if I measure in this direction, I am getting only constant particles A, and if I measure in this direction, I am only getting the constant particle B. Means this is the ability of crystalline solid, this is an ability of crystalline solid to change the value of physical property when measured in different direction, because if you measure this in different direction, we are getting different constituent particles. So that property is called as anisotropy. Again I am repeating it. Ability of this crystalline solid, ability of this crystalline solid to change the value of physical property, to change the value of physical property when measured in different direction. Because if I measure in this direction, I am getting constant particle A, B, A, B. But if I am measuring in another direction, I am getting only constant particles A. If I measure in this direction, I am getting constant particle B. So the physical properties such as refractive index, the value of refractive index will be different when measured in different direction. Okay. Now, the next point of crystalline solid is isomorphous. What is this isomorphous? Iso means same, and this morphous means form. Same form means here two or more substance having same crystalline structure, two or more substance having same crystalline structures are called as isomorphous of each other. What is isomorphous? Iso means same, morphous means form. Two or more different powders, two or more different powders having same structure. Suppose the structure of sugar is cubic. So if another substance is there, or if another powder is there which is crystalline and its shape is also cubic, So sugar and that substance are called as isomorphous of each other. That means what? Two or more substance having same crystalline structure. We'll take some examples. Their examples are NaF, MgO. NaF, MgO. These two are isomorphous of each other. Now if you take their atomic ratio, how many sodiums can you see here? 1. How many fluorines can you see? 1. So its atomic ratio is 1:1. What is the atomic ratio of MgO? How many magnesiums are there? 1. And how many oxygen is there? 1. That means its atomic ratio is also 1:1. So their atomic ratio is same. We will take another example, that is CaCO3 and NaNO3, that is calcium carbonate, sodium nitrate. What is the atomic ratio? How many calciums can you see? 1. How many carbon is there? 1. How many oxygens are there? 3. So its atomic ratio is 1:1:3. What is the atomic ratio in sodium nitrate? Sodium is 1, nitrogen is 1, and oxygen is 3. So its atomic ratio is 1:1:3. And these two are isomorphous of each other, and they are having same atomic structure. But that doesn't mean if the compounds are having same atomic structure, they will have same structure. Same atomic ratio, they will have same structure. Now, coincidentally, this has happened that they are isomorphous of each other and their atomic ratio is same. That doesn't mean those having same atomic ratio should have same structure. It is not compulsory. Okay. So that is, this atomic ratio is not a criteria to tell whether it's an isomorphous. These examples you need to remember. Okay. The next point is polymorphous. Next one is polymorphous. Poly means many and morphous means form. If a single substance crystallizes into two or more forms under the different set of condition, means a single powder at lower temperature it will show another shape, but higher temperature it will show another shape. This is called as polymorphous. Poly means many, morphous means form. A single substance which can crystallize into two or more forms under the different set of condition. What is different set of condition? It can be condition of temperature and pressure. Suppose we'll take an example of carbon. Carbon has two crystalline form. One is diamond and one is graphite. In chemistry we say this as allotrope. Carbon exists in crystalline form in two different forms, that is diamond and graphite. At lower temperature we'll get graphite, and at very high temperature we'll get diamond. This means, in simple language I'll tell you, this diamond and graphite both are carbon, but at lower temperature we'll get graphite, and if it can withstand very high temperature then it will be converted into diamond. That means diamond has to take very high temperature to become so precious stone. Okay. Carbon exists in two crystalline forms. One is graphite and one is diamond. Graphite it is at lower temperature, while diamond it is at higher temperature. So students, you also need to study very hard to become a diamond, because diamond also has to withstand very high temperature to become a diamond. Otherwise, it will remain as graphite. Okay students, now we'll now move towards amorphous solids. In crystalline solids, we have seen that it has long range definite repeating pattern. It has long range definite repeating pattern. But in amorphous solid, there is very short range definite repeating pattern. What is meant by short range definite repeating pattern? Suppose this constituent particle is A, then this A constituent particle B, then this is A, then B, then we will get A, B, this is B, this is B. So initially you see there is definite repeating pattern, and then there is irregular pattern. That means what? These amorphous solids have short range definite repeating pattern. It has short range definite repeating pattern. In crystalline solids, we have seen they have sharp melting point. They are having sharp melting point. But in amorphous solid, in case of amorphous solids, they have wide range melting point. Wide range melting point. That means what? If you take an example of plastic, because plastic is an amorphous solid. If you heat the plastic, initially it will become soft, then it will melt. That means what? If it is having melting point, suppose 170 degrees Celsius. How much students? 170 degrees Celsius. Means at 100 only it will become soft, then initially it will melt. So it will melt from 100 to 170 degree Celsius. Means in the range it will melt. It will not melt at exact 170. In one range it will melt. Okay. The next point is, we have seen that crystalline solids are anisotropy. Anisotropy means what? The ability of crystalline solid to change the value of physical property when measured in different direction. But this amorphous solid is isotropy. Isotropy means value of physical property will not change when measured in different direction. Suppose the constant particles are A, B, then again A. There is no regular repeating pattern. So here it is B, B, A, B, A, B, B. So if you measure through any direction, if you measure through this direction, you will get constant particle A, B, A. At least you will get A and B. If you measure in any direction, you will get both the constant particles, that is A and B. So the value of physical property will not change when measured in different direction. This is called as isotropy. This is called as isotropy. Okay. One more point, that is, these amorphous solids are called as supercooled liquid. This is called as supercooled liquid. Now what is this supercooled liquid? These amorphous solids are actually called as pseudo-solid or supercooled liquid. I will give very nice example. Have you seen butter? Butter is a kind of solid, but we cannot call it as perfect solid. It is somewhat little jelly type, means actually it is a super cooled liquid. If you cool the liquid, it will become a solid, but it is not a perfectly solid, so it is called a super cooled liquid. And you know that liquid has tendency to flow under the gravity. The gravitational force will pull the liquid downwards. So if you carefully observe the window pans, the glass which is fit to the windows, you see after many years the glass will become thick at the bottom and thin at the top. जे घरची ग्लास आहे ती खालची जाडी वाढते, वर काय होते पातळ होते. What is the reason behind it? Because the glass is amorphous solid, and you know this amorphous solid, it will flow under the gravity. So gravitational force will, suppose this is the glass which is fitted to your windows. Under gravitational force, the liquid in this glass will flow downwards, and so this part will become thick and the upper part will become thin. So once in board exam it was asked why the glass of windows will become thick at the bottom and thin at the top. So the answer for this is glass is an example of amorphous solid, and it is an example of amorphous solid, means it is super cooled liquid, and liquid flows under gravity. Okay, so the next point is distinguish between amorphous solid and crystalline solid. This was the question asked at least 4 to 5 times in board exam. What is distinguish between crystalline solid and amorphous solid? Now I already explained you all the points of crystalline solids and amorphous solids, so easily you can write 5-6 points. That is, crystalline solids have definite repeating pattern, it has long range repeating pattern, while in case of amorphous solid it has short range definite repeating pattern. Then crystalline solids have sharp melting point. Amorphous solid does not have sharp melting point, it has wide range melting point. Then crystalline solid shows the property of anisotropy, while amorphous solid shows the property of isotropy. Okay, so like this you can at least write 4-5 points about the distinguish between crystalline solid and amorphous solid. Now we'll move for the next point, that is crystalline solids are, now this I will explain in short. Crystalline solids are classified into, in this chapter we are going to focus more on this crystalline solid. Crystalline solids are classified into 4 types. First one is molecular solid, second one is ionic solid, metallic solid, and then it is covalent solid. So these crystalline solids are classified into 4 types: molecular solid, ionic solid, metallic solid, covalent solid. Now this molecular solids is also classified into 3 types. First one is polar molecular solid, non-polar molecular solid, hydrogen bonding molecular solid. Now what is meant by this polar molecular solid? What is meant by this polar molecular solid? If you take, can you see here, if you take an example of HCl, if you take an example of HCl, As you know that chlorine is more electronegative than hydrogen. Chlorine is more electronegative than hydrogen. So this chlorine will acquire partial negative charge, while this hydrogen will acquire partial positive charge. That means what? The two poles are created. So it is called as polar molecular solid. Now what is meant by this non-polar molecular solid? If we take an example of Cl2, this one bond means how many electron, students? This one bond means 2 electrons, and these 2 electrons will be exactly in the center because both the atoms are chlorine, so they are equally electronegative, so they will not pull electron towards itself. So the electron will lie exactly in the center, so no poles will be created in this. And third one is hydrogen bonding. Now when a molecule will show hydrogen bonding, it will show hydrogen bonding. There are two conditions for hydrogen bonding. First, hydrogen should be present, and second, it should be present on more electronegative atoms such as oxygen, fluorine, oxygen, nitrogen, FON, we say it as phone, fluorine, oxygen, nitrogen. Now I will give an example to you about hydrogen bonding. Now, as you know that when liquid is converted into solid, it should decrease in size. The density should decrease. When liquid, as you know that liquid, there is little bit gap into it. When it is converted into solid, the molecules should come close to each other. Means its density should decrease. But you try it at home. This already I have discussed that when you keep a glass of water into the refrigerator, and when it will convert into ice, its volume will increase, and this is unusual behavior of water. So we say it as anomalous behavior of water. Why this happens? Because the structure of water, as you know, formula of water is H2O. So it is HOH. So you see here hydrogen is present, and it is present on more electronegative atoms like oxygen. So I told you more electronegative atoms we need to take as fluorine, oxygen or nitrogen. If I take another molecule of water, you see this oxygen is more electronegative, so it will show intermolecular hydrogen bonding with another hydrogen. This is called as intermolecular. Intermolecular means what? Intermolecular means what? It is the hydrogen bonding between two different molecules. This is first molecule, this is second molecule. So in 11th you might have learned this is called as intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Then this oxygen will pull this hydrogen. Suppose this is I am an oxygen, this is one hydrogen and this is one hydrogen. So if this hydrogen is pulled by another oxygen and this hydrogen is also pulled by another oxygen, I'll take more space. So the density of water, when you keep into the refrigerator, when you convert into ice, it will increase. One more I'll draw this way, and the empty space is created in between. We say it as air sac, and because of this ice floats on water, because it forms an empty space, and in empty space air is trapped. So if you carefully observe the ice cube, you can see the bubbles trapped into it. Because of this, it makes ice lighter than water. Now moving on to the next one, that is ionic solids. in ionic solids, you know, two ions should be present, cation, anion. Suppose an example of NaCl, Na plus, Cl minus. So do you know what is the force of attraction in ionic solid? Yes, it is electrostatic force of attraction. It is electrostatic force of attraction. The attraction which holds two atoms together. In case of NaCl, we never show Na bond Cl. We never show bond between Na and Cl. We simply write as NaCl because there is strong electrostatic force of attraction between them. This is called as ionic solid. What is the metallic solid? Metallic solid means you take any metal. Suppose copper metal. Copper conducts electricity. So all atoms are made up of copper and there are free electrons into it. And because of this free electron conducts electricity and they are even good conductor of heat and electricity. So this is of metallic solid. And the last one is covalent solid. The last one is covalent solid. Now you know in covalent solid there should be a covalent bond into it. What is meant by covalent bond? The bond formed by mutual sharing of electron. Here in your notes, detailedly I have explained you what is diamond, what is graphite and what is fullerene. These three can be asked for short notes. Write note on diamond, write note on graphite. I have detailedly written the notes of it. If you have any doubt, you can ask me. Okay, now we'll move for the next one. Yes, we'll move for the next one, that is known as lattice. A regular arrangement of constituent particles in three dimensional. Now, many times I am saying the word constituent particles.